So basically, challenge number 5 optional outlines a problem where there's one bead C and one bead D floating in space, sort of near each other. And we know that bead C has a charge Q of 2 times 10 to the negative 9th coulombs, or 2 nanocoulombs, and D has a charge of negative 1 times 10 to the negative 9th coulombs. So this is C is positively charged and D is negatively charged, so inherently they're going to attract each other. And our goal is to find the final velocity of C and D right before they hit each other. And we know that they have the same radius or the same size, and that the mass of C is 1 gram and the mass of D is 2 grams. So to do this, we first have to use we have to find the potential energy of the system, and then we can use the conservation of momentum to find VF for both, which is the velocity final for both of them. So in order to find the potential energy, first we know that potential energy is equal to KQ1 Q2 over R, and I outlined that here, and the value is just 1.8 times 10 to the negative 6. We also know that energy is conserved 100% of the time, so U is equal to, this is just a different way of writing it, it's KE, the kinetic energy 1 plus kinetic energy 2, and remember that this is bead C, this is bead D, so when I say 1/2 mass C velocity C squared, this is the mass and the velocity of bead C and the mass and velocity of bead D. So basically, now that we know the potential energy, we can use the law of conservation of momentum. So we know that mc vc, which is mass mc velocity of c, equals md vd. So now we can solve for one of them. I just chose C. So the velocity of C is equal to mass of D divided by mass of C multiplied by the velocity of D. I'm just going to call them mv and vc and md and mc just to keep it simple. But now we have an expression for vc, which is what we need to continue. So now we can plug that back into the expression that we found for potential energy. So now we have U equals 1/2 mc multiplied by that a quantity that we just found instead of Vc, and we square it because the quantity was squared. But we can replace it with md over mc vd and plus 1/2 md vd squared. So we can simplify this down and just kind of multiply out. These will eventually cancel. One of them will, because this is squared, so this is md squared over mc squared vd. And eventually what we get is something that looks like this, and so it's a lot easier and simpler to deal with. But what we want to do is solve for some, solve for vd, which is what you're trying to find. And remember, we had an expression for vc. It's pretty useless because in that expression is the final velocity of bd, which we don't know. So what we're trying to do here is find an expression for one in terms of the other, so that once we figure one out, we can plug that value back into the first expression and find the other one. But first we have to have an expression like this, which is kind of ugly, but we need to do it so that we can plug in all the numbers that we already know to find the velocity final of d. So this is what it is. It's just under the square root because of the squareds. 2 times the potential energy divided by the quantity mass of d squared over mass of c plus mass of d. And if you plug in all the numbers, the velocity of d, final velocity, eventually comes out to 2.6 times 10 to the negative 2 meters per second. And that's what I got. So now that we have the velocity of d, it's pretty simple to find the final velocity of c, because we had that really simple expression, and all we had to do is plug in vd, which is the only thing that we needed, because we knew their mass. So we have vc equals the mass of, I think that's the mass of d, over the mass of c multiplied by the final velocity of d, which is 5.2 meters per second. So I have it at the bottom. The final velocity of beads in C or D are 5.2 meters per second and 2.6 meters per second. So which actually makes a lot of sense, because 5.2 So C is 5.2 because it weighs 1 gram, and D is 2.6 because it weighs 2 grams. So it's exactly twice the mass of C. So it makes sense that it's exactly 1/2 of the final velocity. If they're pulling on each other with the exact same force, then one will have exactly double the final velocity if it's exactly 1/2 of the mass. Okay.